Hi folks, this is question 3. It's differentiation, so we just have to differentiate. So f dash x is equal to, it's going to be chain rule. I'm going to do the 28, which is their power, multiplied by a 1 that would be in front. And so we're going to get 28, and then 3x to the power of 5 minus 4. And then chain rule applies. So I have to multiply by the differential of what is inside the brackets. And that is just going to be 15x4. 15x to the power of 4. It says you don't need to simplify your answer. I'm just going to do the 15 times the 28 anyway and call it 420 x to the power of 4, 3x5 minus 4. And I won't bother multiplying out the brackets. You might need to, but we'll see what we have to do next. Okay, so by finding g dash x, so we're going to find g dash x here. Now I'm just going to rewrite it as there's a couple of options here. We could use the quotient rule here, or I'm going to try to use the chain rule. So g of x is equal to 3 times 2x minus 7 to the power of minus 1. I'm going to rewrite it as that and use the chain rule. So g dash x is equal to minus 1 times 3 is minus 3. 2x minus 7, and then I'm dropping the power to minus 2, and then I'm going to multiply by the differential of what is inside the bracket, so I'm going to multiply by 2. So we get minus 6, 2x minus 7 to the power of minus 2, and we can change that back to minus 6 over 2x minus 7 squared, like that. Now, if we look back at the question, show that it has no maximum or minimum. So for maximum or minimum, what we always do there is we differentiate and let it be equal to 0. So I'm going to let that be equal to 0. Oh yeah, so this actually works out nicely. So minus 6 over 2x minus 7 squared, okay, is equal to 0. So using laws of algebra, I should be able to bring across the bottom, what's on the bottom there, and multiply it. So if I just bring across all of the bottom, all of that, and I multiply it by the 0 on the right hand side, well, obviously I'm just going to get 0. And that's a kind of the point. So then minus 6 would be equal to 0, and that's not true. So therefore, it can't have max or min. I think that's all you have to show there. Right, we're integrating here then. The integral of e to the 5x it'll just be e to the 5x, then you'll have to put it over 5 because we're dividing by the differential of what is in the power. So I'll just go back on how to differentiate and integrate e to the x, and that should make sense. So it'll be e to the power of 5x over 5, and that's between k and 0. We haven't put the k or the 0 in yet. Now, if I put a k in, it'll be e to the power of 5k over 5 minus, if I put in a 0, it'll be e to the power of 0 over 5. And they're saying that all of that is equal to 9 in the form. So we have to, oh yeah, we have to get k by itself. Right, well, I would multiply by 5 on both sides then. So that would give me e to the power of 5k minus 1 is equal to 45. Therefore, if I bring over the minus 1, e to the power of 5k is equal to 36. Then I'm going to do ln on both sides. ln e to the 5k is equal to ln 46. And yeah, so 5k ln e is equal to ln 46. Now, ln e cancels out to be 1. Therefore, 5k is equal to ln of 46. And k is equal to ln 46 over 5. That's all.